Okay, let's talk about some of the more important sets. First of all, we have the natural or counting numbers. And I always say that these are the numbers that you can hold in your hand because this set includes the following. It's 1, 2, 3, 4, 5, 6, 7, dot, dot, dot. I guess I could have started earlier or stopped earlier and put my dots earlier. But the natural numbers are just numbers that you can count, basically. Like you can have a certain number of them. You don't include 0 in this, and you can remember that because if you just remember, you can't hold 0 of something in your hands. Well, I mean, I suppose you could walk around, pretending you're holding 0 of something in your hand, just like looking at your hand, but people will probably think you're weird. If you want to include 0 in this set, then it becomes the set of whole numbers. Another set that's important that we've already talked about a little bit is the set of integers. So dot, 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 and I'll just start with -2, -1, 0, 1, 2, dot, dot, dot. Basically, with the set of integers, you're taking the natural numbers and you're throwing in 0, and you're also throwing in negatives. Okay? Now we're going to talk about rational numbers. Rational numbers, they're not numbers that are always calm, cool, and collected. No, actually what rational numbers are, they are numbers that could be written as a fraction. So you can write them in the form AB. Now, the confusing thing about rational numbers is they don't have to be written as a fraction, but they potentially can be written as a fraction. And you can't really list all the rational numbers because there's always, between any two rational numbers, you can always find another rational number. So you can't list all of them, but let me just give you some examples of rational numbers. -2 is an example. 0 is an example. 1.8 is an example. Now, here's an interesting one. 0.2735, and I'll make it be 353535 forever, and by doing that I just put a bar over that, and that means that the 35 goes on and forever and ever. You might also write it like this: 27353535 dot, dot, dot. This is also a rational number. Anytime you have a sequence of numbers in your decimal repeating, that's also a rational number, okay? Now, the irrational numbers, those are numbers that their sequence of numbers in them never repeats if they're written as a decimal, and it never terminates. To be a rational number, a decimal has to either repeat like this or terminate like that. Irrational numbers are numbers that are not rational. That makes sense, I guess. In other words, they're numbers that can't be written as a fraction. So some examples of this are square root of 2, square root of 3. Pi is a good example. A lot of people probably know about that one. And then there's another one called E that we'll talk about later. And those are some irrational numbers. Basically, let me show you another one that I always think is kind of interesting. Here's one. 1.020020002 dot, dot, dot. That is actually irrational. A lot of people would say, well, I thought you said if it repeats, it's rational. Well, I did say that, but even though this pattern is repeating, the sequence is not repeating because I'm throwing in an extra 0 every time. So this would definitely be irrational. And then when you get the rational and irrational numbers together, that forms the real numbers. And we'll talk about real numbers. And then the real numbers, you can take those and you can group them with what are called imaginary numbers. And from that, you get the complex numbers. I can't wait to talk about imaginary numbers, and I hope you're going to be as excited about it as me.